back to Algebra 1. This is our final level for Unit 3, which is domain and range of functions. We've talked about domain and range a little bit. We know that domain is another name for the x values, and we also know that range is another term for the y values. Okay, so what we're going to do for number 1, this is kind of going to be a little bit of a warm-up. We're going to skip number 2, but we are going to pay attention to number 1 for right now. Okay. So number 1, again, if I wanted to list out the domain or just show the domain, you could do it like this. You could do your little D colon and then make your little weird squiggly line parentheses and then just start listing your x values, right? We can go least to greatest. It looks like for us, they're already from least to greatest. That's sweet. So we just do -5, -4, -2, 0, and 1. Alright, what I'd like you guys to do as a little warm-up is I'd like you to list out the range, which are the y values, and go for it. Alright, we're back. Again, yeah, the range is just y values. It's good to go least to greatest, so we're going to do that. But if you didn't, it's not the end of the world. So it looks like our smallest one is -1. Then we have 1. Then we have 3. And then we have 4 twice, so I'm only going to list the 4 once. There's our domain and range. But we can also represent this stuff as a table, a mapping, and a graph. There's a lot of ways to represent functions, okay? So if we have something like this, like -5, 4, again, I got my x, I got my y, I got -5, 4, -4, -1, and you could just go down the line, no biggie. Representing it like a mapping, not the most important skill, I'm going to be totally honest with you, but we can do it. We can do it. So I can list my domain out. Go ahead and do that. And then I'll list out my range. So I had -1, 1, 3, and 4. So now all I'm going to do is I'm going to draw arrows to show how these guys are related. So -5 is related to 4. -4 is related to -1. -2 is related to 1, 0, 4, and finally 1, 3. Okay? Now, more importantly, and this is what I really care about, is can we still graph this, right? So we got our x, y axis, and now we're just going to graph this. Best tool to use for graphing is what we use for level 3. This guy right here, the table. So let's use it, right? Let's do -5, 4 to start. -5, 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. And sweet. What I'd like you guys to do is to finish plotting the rest of the points. Do not connect your graph as a line, okay? Let's save that part and talk about that part and go. Alright, we're back. Let's see what we come up with. -4, -1. 1, 2, 3, 4, and then down 1. -2, 1 is -2, 1, 0, 4, and 1, 3 is right here. Alright, just by looking at that, yes, it is a function. But looking at it, you can tell we're not going to get a line out of that. We're not going to get a line out of that. From our level 3, we were getting lines out of this. But here we're not. So what's the difference? What is going on? Well, if we look right here, we're given a list of points. We're given a list. Here, I'm given a full-blown equation. Yes, I can still plot the points and do all that stuff. But there's a lot of other points I can choose, a lot of other inputs. Here, it's specifically telling me to plot these points. So we can't actually make a line out of this because, well, this is where things get confusing, okay? So a line between points shows that I have a bunch of x coordinates I could get. But the dots by themselves show us that these points are just by themselves. That's it. An equation of a line, this guy behaves a little different, right? So let's go to Desmos real quick. Let's go to Desmos like we did last time and see what's going on. So I'm going to type in just any kind of line. I'll just do 2x plus 3. That's the one we had as the example. And you can see I'm getting a line out of this, right? But if I just start plotting some points, like the ones we had for our most recent example, what we just did, you're seeing as I list them, they're not getting connected, right? They're just out in space. Okay? And again, like I was saying, the reason for that is this is just a list of points. This is an actual line that contains really an infinite amount of points. If I kept zooming out, this line, look at my axes. Look at my axes. Whoa. Look how far I'm going out. It doesn't matter how far I go out. I could do this forever. Look, my x-axis, dude, that's 200,000 right there. It's still going with no sign of slowing down. My y's up to 800,000. And really, it just keeps going to infinity. And the numbers just keep getting bigger and bigger. We're getting a little weird. Okay? So when we list out our domain and our range for like points, well, it's really nice because we only have to just list out what those x values are, and for the range, what the y values are, because these are individual points. But if I look at my graph or my line, there's a lot of different points I can get. Some of the points we plotted were like -1, -5. And if I look, yeah, -1, -5, -1, -5. Let's see if I can find it. My apologies. This was 2x minus 3. Now let's find -1, -5. So -1, -5. Yeah, it's right about there. Right about there. Okay? Cool. So we have that point, but yeah, next to it you can see there's -1.01 and -5.02. What the heck? I have an infinite amount of points along this line. So if I was going to list out the domain and range for a line, like I'm doing here, that's impossible. I can't do it. There's just no way. I don't have enough time in my life to be able to do that. So we're going to talk about what you can do. Alright? So, things like this, graphs that look like this where the points are disconnected, this is called discrete. This is a discrete graph. Alright? And in fact, this is also going to be a discrete graph. I'm just going to plot these points real quick. -3, -4 be about here. -1, 2 be here. 0, 0. -3, 5 up here. And then we got 2, 4. Again, these guys are all disconnected. This is discrete. Okay? Based off that, what's a good definition we could use for a discrete graph? I want you guys to talk about that, and let's see what we come up with, and come up with our own definition. And go. All right. I'm not going to say the definition right now for this video, because depending on my class, we might have come up with something a little bit different that's unique to our class, okay? But the main idea with discrete is that none of the points are connected, okay? They're just scattered, and that's it. But if we look at something like this, it kind of continues, right? Our line on Desmos continued. We call it continuous. These are continuous graphs. Continuous. They're all continuous. All these ones down here. In fact, you can see it right there. It's continuous, okay? So now, how do we get the domain and range of these continuous graphs? Because like I said, we'd be here a long time if we try to list. This is where the inequality comes in handy. I don't know if you guys remember this, but inequalities are something like this. We're going to put this to the side right now, okay? And you can write this somewhere on your page. You can write this somewhere on the side, but I just want to kind of list it out right now and just get an idea of what an inequality is. So inequalities, this is greater than, this is less than, And those are inequality signs. So they work kind of similar to equal signs, right? You could have like 3 plus x is greater than 2 or something like that. You can have something like that. We're not going to worry about this too much, but just to show you how it's read, 3 plus x is greater than 2. 3 plus x is less than 2. Okay? But we also have a different version, right? We also have this guy and this guy. This guy is also greater than, but it's specific. It's greater than or equal to. Okay? This one's less than or equal to. Okay? Kind of a good way I remember to show like if something, which side is greater than, because you can also read this the other way. You could say, oh, 2 is greater than 3 plus x. You could say 2 is less than 3 plus x. Okay? Really what determines it is like this alligator mouth example. So whichever side, like you can think of an alligator as pretty hungry. So whichever side's bigger, that's what the alligator wants to eat. They want to eat the bigger side. So he wants to eat the 2 because the 2 is greater than. He wants to eat the 3 plus x because it's greater than the 2. Okay? So that's kind of how that works. You could show it's greater than. All right? Well, we're going to run with this idea and use it with our continuous graphs. Okay? So let's start with our domain. We know our domain are the x-coordinates on our graph, so on the x-axis. So that's left to right. So we know the left side is going to be like our negative side, and this is going to be our positive. So what is the smallest x-coordinate we can get out of this? Well, it looks like -1, -2, -3 is the farthest we can go, right? What is the greatest? What's the greatest? Well, it's not at 5. Like I showed you on Desmos, this arrow is going to continue in this direction forever. So the idea of forever is called infinity, actually. And remember, infinity symbol looks like this. Looks something like that. So what we could do to show the domain of this is we could say that the x values are all going to be greater than -5, right? So I can write this as x is greater than -5. Does it include -5? Because if it does, we might want to change this up, right? If it does include it, we want to say it's greater than or equal to 5. And in fact, it goes to -5. It touches -5. Okay. All right, guys. I totally made an error, so I had to cut some of that. Okay. Let's rewind a little bit. Okay. So what is the smallest x value or x coordinate I can get on my graph? Well, if I look, it's -1, -2, -3. That is the smallest one. And if we look, everything after that is greater than -3, right? This continues infinitely in this direction. So the way I can write this, kind of how I was reading it with my inequalities, right? I could say that -3, or I could say that my x values are going to be greater than -3. So for my domain, I can write x is greater than, alligator wants to eat it, x is greater than -3. Does my domain include -3? Is that one of my x values? And yeah, actually it is. So if it includes it, I might want to fix this a little bit. It's greater than or equal to. So I need to include this little guy down here. Okay? That's my domain of this graph. That's the only way I can represent it without trying to list it out. Okay? What about my range? All right? Well, the range is a little funky, but if we think about this line, I know it's starting to look like it's going to get really horizontal, but it's still going to continue infinitely forever, no matter how small of a climb that line is going up and the other one is going down. So again, the range is concerned with our y values. So if we think, all right, our y values are climbing, 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 are they ever going to stop climbing? No, they are not. Are they also ever going to stop decreasing? No, they are not either. So it goes from negative infinity to infinity. So the way you can represent that is, first of all, we know we have a y. We're talking about our range now. We know that the y is definitely going to be, it's going to at least be greater than infinity. But it's also going to have to be less than positive infinity. Right? So that's how we can represent it. Negative infinity down here, positive infinity up here, and my range encompasses all those values in between negative infinity and infinity. This shows that y is in between negative infinity and infinity. And can I include infinity? I want you to talk to a partner for a second and discuss, can we include infinity just like we did with the negative 3? And go ahead. All right, we're back. Turns out you can't. Infinity will never reach it. It's just kind of this concept, so you have to leave it as y is greater than negative infinity and less than positive infinity. Okay? That's all we have to work with. Let's try another one. Let's try it with number 5. Okay? If we look at number 5, what is the smallest x value I can get, right? So I'm determining what's my smallest and what's my highest. That's kind of what I did for this last one. Well, my smallest for my domain, my x values, well, this arrow indicates it's going on forever and ever and ever in that direction. So my smallest is technically negative infinity. My greatest, if I keep going this way, it'll never stop. So it's going to be going infinity in that direction. And my x, my domain values, are sandwiched in between negative infinity and infinity. So just like I did up here, I'm going to do it like this. That x is greater than negative infinity. It is also less than positive infinity. Is that the same case for my y values? Yeah, it is. Y is never going to stop increasing, and it's also never going to stop decreasing. So my range values, encompassing all my range values, to get all of them, I would have to include everything in between negative infinity and infinity. Okay? What I'd like you guys to try to do is I want you to try number 4 and see what you come up with, and go. All right, we're back. Let's look at this guy. So let's start with domain. All right, the lowest domain value, this arrow shows it's going in the left direction, the negative direction, forever and ever and ever. This arrow shows it's going positively this way. So all my x values, in order to get them, I have to go from negative infinity to positive infinity. Y, my range, is a little bit different, right? My lowest value, well, it actually looks like this graph kind of stops right there, right? It kind of looks like it's starting to like come back just being horizontal like this, which is kind of hard to see. And really, you can kind of interpret this one a little different ways, just because the arrows seem to be a little not clear, let's say. They're not clear. I'm going to assume that they're flattening out. So what are they flattening out to? What's that y value? Well, it's -1, -2. So -2 is my smallest y value. And do I have a greatest y value? I do. It's a +2 up here, right? It's a +2 right here. So to get all these range values, it's between -2 and 2. So my range can be written like this. Y is greater than -2. It's also less than +2. I'm going to go ahead, I'm going to stop the notes video, and if we need to continue this tomorrow, we will do some in class on Thursday, okay?